we're going to be talking about combinations. A combination is a grouping of objects or events in which the order you group them in does not matter. For example, a student can choose book 1 and 2, or he can choose book 2 and 1. Since the order doesn't matter, the two arrangements are the same combination. So you can use a table to find all the possible combinations, or you can also use a tree diagram to find all the combinations. So when you are copying this into your notes, you do not need to write the example down. All right, our first one is how many different combinations of 2 books are possible if you choose from a list of 5 books that Ms. Cato gave you. Okay, so up along the top here, we're going to use a table. Okay, so up along the top here, we list book 1, book 2, book 3, book 4, book 5, and along the left side, we list book 1, book 2, book 3, book 4, book 5. Okay, so when we're listing all the different combinations, well, obviously, book 1 you can't choose book 1 first and then combine it with book 1 again. Okay, so that is not a combination. Same thing goes with book 2 and book 2, 3 and 3, 4 and 4, and 5 and 5. Okay, but if you look at it, you have book 1 and book 2, book 1 and book 3, book 1, book 4, book 1 and 5. All right, and 2 and 1, 2 and 3, 2 and 4, 2 and 5, 3 and 1, 3 and 2, 3 and 4, and 3 and 5. 4, 1. So you see how this pattern goes. We just combine the book on the last column versus on the left column versus the book up on top, and last row is 5, 1, 5, 2, 5, 3, and 5, 4. Okay, so now the thing is, we're talking about combinations, so that means the order is not important. So 1 and 2 is the same thing as 2 and 1. So let's just cross out 2 and 1. 1 and 3 is the same thing as 3 and 1. Okay? 1 and 4, same thing as 4 and 1. And 1 and 5, same thing as 5 and 1. Okay? 2 and 3, same thing as 3 and 2. 2 and 4, same thing as 4 and 2. 2 and 5, same thing as 5 and 2. 3 and 4, same thing as 4, 3. And the same thing goes with 5 and 3 and 3 and 5. And then 5 and 4 and 4 and 5. So if we look at it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 different combinations. Okay? All right, so that's the easiest way of doing that. It's important to remember that the order does not matter. Okay, that's why we're able to mark all these out down here. All right. As a chef, my friend Emma offers 4 vegetable choices. Okay, broccoli. Okay. Broccoli and squash and peas and carrots. All right. Each person can choose 2 vegetables, and using a tree diagram, how many different combinations of 2 vegetables can a person choose? Well, you can do broccoli and squash. I'm just going to use S for squash. You can do broccoli and peas. You can do broccoli and carrots. Okay? Or you can do squash and broccoli. All right. well, we've already got broccoli and squash, so that cancels out. We can do squash and peas, squash and and carrots. Okay, we're not going to do squash and squash because you're not going to have a double order of squash. Okay, you can do peas and broccoli, which we've already have broccoli and peas, so we'd get rid of that. Peas and squash and peas, we've already got that. And we have peas and carrots. We don't have peas and carrots yet. Okay, and then if we look at carrots, we have carrots and broccoli, which we already have that right here, broccoli and carrots. Okay, we have carrots and squash, that's right here, squash and carrots. And we have carrots and peas, which we already have that right here. So in all together, if you don't count the order, we have 1, 2, 3, 4, 5, 6 combinations. So that's the easy way of choosing and finding out how many different combinations there are.